So we'll continue with our discussion on these metathesis or double displacement, also called double replacement reactions. And this first line here on the worksheet, this is actually from the previous video. So I identified what ions we would cancel out on both sides of the equation, and those are called the spectator ions. So in the last example that we had, those would have been potassium K plus and then nitrate NO3 -1. So we're going to continue our practice here and we're going to follow these steps to writing net ionic equations. So step one will always be to write the balanced molecular equation. And then from there, we're going to dissociate or break down into ions all the strong electrolytes. We would leave any weak electrolytes in solution as a molecular form. We're going to cross out anything that remains unchanged on the left side and the right side of the equation. So we'll cancel out our spectator ions. And then in the end, we're going to get to step 4 here, where we'll write our net ionic equation with all the species that remain. So let's look at sample exercise 4, where we're asked to write the net ionic equation, and we're told that this is going to be a precipitation reaction when we mix aqueous solutions of our first reactant will be silver nitrate, and our second is potassium phosphate. So let's see what this would look like if we were to write this out. So first we have AgNO3, so this will be our silver nitrate. We know that it's aqueous because we're told this is a precipitation reaction. And then we have potassium phosphate. So that would be K3PO4. Phosphate has a -3 charge, potassium's +1. So that's going to be our ionic, our salt formula here. And then when we mix those solutions together, on the product side, we have two potential products. So first would be Ag3PO4, silver phosphate, and then we're also going to produce potassium nitrate. So we're told it's a precipitation reaction. And if you recall that nitrates will always be aqueous in solution, there's no exceptions. So I know that my silver phosphate must be my precipitate. So now we're going to need to balance. So step 1 of writing our net ionic equations is to write the balanced molecular formula. And if you can tell from the potassium here, this is unbalanced. So I know that I need 3 potassiums. That would give me 3 nitrates over here. So then I'm going to go back on the reactant side and add a 3 in front, and that would balance my silver. So now I've added 3 AgNO3. I still have 1 potassium phosphate. I still have 1 silver phosphate on the product side. And then I also have that coefficient of 3 in front of my potassium nitrate. So this is step 1 complete. Now let's move on to step 2, where we're going to break apart these salts, these ionic compounds, into their ionized forms that they would appear in solution, in aqueous solution specifically. So I'm going to have 3 Ag and 3 NO3. And the phase for these would also be aqueous, but to save space, I won't write them. Now I'm going to break down my potassium phosphate. So I'm going to get 3 K plus and then 1 PO43 negative. And over here on the product side, I'm going to keep my solid together. Even though this is the total ionic formula or equation here, I'm still going to keep together my precipitate, my solid, because that's how it would be in reality. And then I also have my other aqueous, we'll call it a product, 3 K plus, and then I'm going to also have 3 NO3. So now in step 3 here, we're going to write what's called that net ionic. We're finally here, the net ionic equation, and we're told to cancel out any of those spectator ions. So nitrate is in the same form, 3 NO3 on both sides, aqueous. We also have 3 K plus on each side. So what I'm left with to write in my net ionic equation will be the 3 Ag plus. And then we see 1 PO4, 3 negative, that combines, and then I get that 1 mole of Ag3 PO4 solid over here. This is my net ionic equation, and my spectator ions will be the K plus and the NO3 negative. So we'll continue with a discussion on acids and bases and neutralization reactions in the next video.